Hello friends, welcome to another video of SWA Environment Consultants and Engineers. This is Water and Wastewater Quality Testing Lecture Series Part 1. In this video, we are going to learn about the measurement of total solids into the water sample. Total solids which contains suspended solids, dissolved solids, fixed solids and volatile solids as per AFA 23rd edition method 2540. So now let's start the video. So in this video, we will going to learn about the brief introduction first. What are the solids and what are the types of solids available. Then we will move to the principle of measurement for measuring the TSS, TDS, VSS and FSS. Then we will see which equipments will be required to perform the procedure. Then we will see the procedure of analysis in two parts. In first part, we will see the procedure of measuring TDS and TSS, and in second part, we will be seeing the procedure of measuring VSS and FSS. Then we will see the calculation of all the parameters, and lastly we will discuss about the measurement uncertainty. So now let's start the video by having a brief introduction about the total solids. So first is total solids. The combination of total suspended solids as well as total dissolved solids is referred as total solids. So basically whatever solids are present into the water sample are known as the total solids. These are made up of total dissolved solids and total suspended solids. So what are total dissolved solids? They are dissolved completely into the water. They can pass through the standard filter paper of pore size 2.5 micron. So we can say that the size of the dissolved solids are less than 2.5 micron. So this type of solids are referred as total dissolved solids. Second is total suspended solids. So the solids which are visible clearly in water sample is known as total suspended solids. They are available as a suspension into the water. So they cannot pass through the standard filter paper of 2.5 micron. So we can say that the size of total suspended solids are more than 2.5 micron. So such type of solids are referred as total suspended solids. The suspended solids are made up of two other solids. First is total volatile solids. Basically the volatile suspended solids are the solids which ignites at 550 degrees centigrade. So if we ignite the suspended solid at the high temperature of 550 degrees centigrade, so which solids are lost, those solids are referred as volatile suspended solids. So basically these solids are airless and can be lost by ignition at high temperature. Second is fixed suspended solids. So after ignition of total suspended solids at 550 degree centigrade temperature, whichever solids are remaining, they can be referred as fixed suspended solids. So this was brief introduction about the solids TDS, TSS, VSS and FSS. So now let's understand the principle of measurement of measuring suspended solids, dissolved solids and volatile solids and fixed solids. So now let's understand the principle of measurement for suspended solids and dissolved solids. So let's start with the measurement of suspended solids first. So basically you have to pre-weight the standard filter paper and filter the well mixed sample from the filter paper. After filtration, you will be able to see the suspended solids on the top of the filter paper. So you have to dry the filter paper which is containing suspended solids in oven at 103 degrees centigrade plus or minus 2 degrees centigrade of temperature variation is acceptable. So basically the temperature can be between 100 to 105 degrees centigrade. So after drying it, post weight the filter paper, and whatever increase in the weight of filter paper you notice, that represents the total suspended solids into the sample. Same goes with the dissolved solids, but you have to well mix the sample and filter it from standard filter paper and collect the filtrate in pre-weighted beaker. Okay, so you have to in TSS we measure the suspension, and here in TDS we have to collect the filtrate into the beaker which is pre-weighted already, and evaporate that filtrate in oven at 180 degree temperature. After the evaporation, whatever residue is remaining into the beaker, that represents the total dissolved solids. So we can get the amount of TDS by post-wetting the beaker. Now let's understand the principle of measurement for VSS and FSS. So the filter paper which is containing total suspended solids is ignited in muffle furnace at the temperature of 500 to 550 degree centigrade. At this high level of temperature, some solids will get lost and some will be remaining in the crucible. So whatever substance is left in the crucible, that represents the fixed solids, and while the substance that burned away and lost, they are known as the volatile suspended solids. So we can calculate the amount of remaining substances. We can subtract the fixed solids from suspended solids, and we can know the amount of volatile solids. So this was the basic principle of VSS and FSS. So now let's see which type of equipments will be required to perform this procedure. So in instruments, we will require oven to dry the filter paper and evaporate the sample for TDS and TSS. This is filtration assembly to filter the sample. The weight balance to pre-weight and post-weight the beaker, the crucibles and filter paper, and muffle furnace for measurement of VSS and FSS. This is a muffle furnace will be used for ignition. So in instruments we have seen, and now let's see which type of glasswares we will require. So firstly we will require a desiccator containing silica gel. So desiccator will provide the desiccation, and silica gel will soak the moisture from filter paper, beaker and crucibles. These beakers will be containing the sample for measurement of TDS. The measuring cylinder to measure the sample. This crucible, this silica crucible will be used to measure the VSS and FSS. And lastly, we will require the standard filter paper which will be used to measure the TSS. So now let's see the procedure of analysis for TDS, TSS and VSS, FSS. So we will be understanding this procedure in two parts. In first part, we will understand the procedure of analysis for TDS and TSS. And in second part, we will understand the procedure of analysis of volatile suspended solids and fixed suspended solids. So let's start with the understanding procedure of TDS and TSS. So now let's see which kind of interference can interfere the procedure of total suspended solids and total dissolved solids. So firstly, we will understand about the total suspended solids. So very firstly, the pores of filter paper may be blocked by the small particles. So in this case, to prevent this kind of interference, you can apply the reagent grade distilled water on filter paper to clear the pores. Secondly, if sample is containing a very high amount of visible total suspended solids, if you see it visibly that the TSS are in high amount, so you can consider the reducing the sample, or you can dilute the sample as per your requirement. Generally, as per our experience, if the sample is sticky, then till 4000 to 5000 milligram per liter of sample you can take without dilution, and you can take the volume 50 ml. If sample is non-sticky, then you can go up to 8000 to 9000 milligram per liter. But in case you observe the sample is dense and there are more visible suspended solids, you can dilute the sample. Or third way, you can increase the diameter of the filter paper. So whichever is possible for you, you can proceed with that. Third is organic matter can be lost while drying for long. This is very important. You have to note this, and you have to clear conceptually about this. So basically, the filter paper is also made of ashless material. So in case you dry the filter paper for long time, so the TSS also can be lost, and as well as the filter paper also lose the weight. So after that the weight variation will occur, and you will be having the wrong results. So you have to take care of this very carefully. And another point, if you measuring the volatile suspended solids, in that case also it will be a problem. So make sure you dry the filter paper in oven less than 1 minute at the temperature of 102 degree or 103 degree centigrade of temperature. This will be the ideal condition to dry the filter paper. In case if you have to be more accurate, you can check the filter paper after 20-30 minutes. If it is dried already, you can take it out. Now let's move to the understanding of interference in total dissolved solids. So salts like calcium, magnesium, chloride or sulfate can capture moisture very fast. If your sample is having this kind of salts, they are able to capture the moisture very fast. So in that case, you require prolonged drying. So you have to dry the filter paper. So you have to evaporate and dry the beaker or the petri dish, whatever you are taking. So after that, this will give you more accurate results. So if you suspect such kind of salts are present in your sample, so provide them prolonged drying. And second is some organic matter which are present as dissolved solids. So they can be decomposed and also they can release the carbon dioxide while drying the sample. So in that case, some amount of the TDS may be lost. So there is no remedy for this, but you have to take care and you have to be aware about that. So this can also happen. So now let's move to the step-by-step procedure for measuring the total suspended solids and total dissolved solids into the sample. So now let's start with the procedure of measuring the TDS and TSS in given sample. Here we are having the sample of aeration tank. In this sample, we will measure the TSS, TDS first, and then VSS and FSS. All of the parameters we will measure in this sample. So firstly, take one standard filter paper for measuring the TSS, 150 ml beaker for measuring the TDS, and one silica crucible for measuring the VSS and FSS. Take all of them, wash the beaker and crucible properly with tap water and still water, clean them and put in oven at 100-degree temperature for approximate 30 to 40 minutes. After 30-40 minutes, take out them and put it in the desiccator which is containing silica gel. So the moisture will be soaked by the silica gel present into the desiccator, and the crucible, filter paper and beaker will be dried properly. Whenever you are proceeding all of these procedures, make sure you wear gloves so that the moisture on your hand can be prevented to transfer on the equipments and the further weight variation can be avoided. Now after putting them in desiccator, take out them and take a pre-weight of filter paper, beaker and crucible and note them. Now we will move further. So after taking the pre-weights, let's measure the 50 ml of sample. This is the sample of ETP aeration tank. So whenever you are taking sample, make sure you mix the sample properly. After mixing the sample, measure the required amount of sample. Here we are taking 50 ml of sample. After measuring the 50 ml of sample, here we are having the filtration assembly. We will place this filter paper into the filtration assembly.
Sure.
Now after placing the filter paper into the filtration assembly, we will start the assembly and filter this sample. So after the filtration is complete, you will be able to see this type of TSS which is collected on the filter paper. Then after, take out the filter paper carefully and put it in petri dish. Now this petri dish will be go in oven at 100 centigrade of temperature. And for TDS measurement of the same sample, here we are having the filtrate into this. We will measure this amount of sample. So here we can see approximately 47 ml of sample is collected. So we have added 50 ml and we collected the 47 ml of filtrate. The reduction of sample is because we have some amount of TSS and as well as some amount of water may be soaked by the filter paper also. So this filtrate we will put in pre-weighted beaker for measuring the TDS. So here we are having this pre-weighted beaker. We will transfer this in pre-weighted beaker. We will transfer both the filter paper and the beaker into oven. Firstly, at 100 degrees centigrade temperature for filter paper for 30 minutes. After the filter paper is dried, take out the filter paper, again put it in desiccator and increase the temperature of oven at 180 degrees centigrade so that the amount of filtrate for TDS will get evaporated. After the water sample is evaporated and TDS remaining into the beaker, take out the beaker also and put it in desiccator. Take post weight of both of them for filter paper and beaker and note the readings. After that, we will move to the calculation part. Now let's see the calculation of TSS and TDS. So the formula for calculation for TSS is W2 minus W1 into 10 raised to 6 divided by volume of sample taken in ml. So here W1 stands for the initial weight 1.29233 gram and W2 stands for the final weight which is 1.36568 grams. Okay, so we will apply the values to the formula. So the answer will be 1467 milligram per liter, 1467 milligram per liter. So this is for TSS. The same formula applies with TDS also. W2 minus W1 into 10 raised to 6 divided by volume of sample taken. So here the W1 initial weight of the beaker was 49.72129 gram and the final weight was 49.77490 gram. So if we apply the values to the formula, then the answer will be 1072.2 milligram per liter. So this was the calculation of TSS and TDS for the sample. By the help of these formulas, you can calculate the TSS and TDS. Now let's see the measurement of volatile suspended solids and fixed suspended solids. So now let's see which kind of interference can be there while measurement of the volatile suspended solids and fixed suspended solids. So firstly, as we have seen initially in interference of TSS, the negative errors can occur in VSS if the filter paper is dried for long time, as we have discussed, and I have made a point at that time that you have to be careful while drying the filter paper for measurement of TSS in case the filter paper is dried for long time. So the filter paper can lose the weight and the negative errors can occur. So you have to be careful for that. And secondly, highly alkaline in residue. Residue is highly alkaline, then they can react with the silica at high temperature and they can also give the variation in final result. So these are very basic and important interference which we have to take care of. Now let's move with the step-by-step procedure of measuring VSS and FSS. Now let's see the measurement of VSS and FSS in given sample. So let's recall again the definition and principle of measuring the VSS and FSS. So basically what we have studied in definition is the VSS is the volatile suspended solids which is part of total suspended solids, and the FSS is fixed suspended solids. So basically the VSS is the organic matter present into the total suspended solids and FSS is inorganic part which is present into the total suspended solids. So basically there is nothing much technical to measurement of it, but you have to conceptually clear about the VSS and FSS. So basically what we will do in further for measuring the VSS and FSS is we will take this silica crucible which is pre-weighted already and the filter paper which we have collected the TSS on. We have dried it properly, we have calculated the TSS already. Now we will put this filter paper into this silica crucible. This silica crucible will be transferred into the muffle furnace at the temperature of 550 degrees centigrade. So at this level of high temperature, whatever organic matter are present into this TSS will be lost. Whatever remains into this silica crucible will be your fixed suspended solids. Let's put this silica crucible into the muffle furnace. After putting it in muffle furnace, wait for 30 to 40 minutes to ignite this. After ignition, carefully by wearing gloves and with the help of forceps, take out the silica crucible, put it in desiccator. This kind of fixed suspended solids will be visible after the ignition. Now, after putting the crucible desiccator, take out them and take the post weight of crucible and note as W2. After that, let's move to the calculation part. Now let's understand the calculation of volatile suspended solids and fixed suspended solids based upon the pre-weight and post weight of crucible. So now let's see the calculation of VSS and FSS. So the formula of calculation is FSS milligram per liter is equals to W2 minus W1 multiplied by 10⁶ divided by volume of sample taken. So sample was taken 50 ml. We will use that 50 ml again here. So W1 stands for the initial weight of the crucible, which was 55.28820 gram, and W2 stands for the crucible which is containing residue after ignition. So that is W2 55.31677 gram. So we will apply the values to the formula. So the answer will be 571.44 milligram per liter. This amount of FSS is present in our sample. And if we want to calculate the VSS, then we have to subtract the amount of FSS from the total suspended solid. So VSS is equals to TSS minus FSS. So TSS was 1467 minus FSS is 571.44 gram. So the volume of volatile suspended solids will be 895.56 milligram per liter. So this was the calculation of fixed suspended solids and volatile suspended solids. So let's see the measurement uncertainty for TSS, TDS, VSS and FSS. So firstly, let's start with the total suspended solids. So the concentration of 15 milligram per liter was analyzed by 2 analysts for 4 samples of 10 determination. So standard deviation derived was 5.2 milligram per liter. In percentage, that will be 34.66%. Same for the concentration 240 milligram per liter. The standard deviation in milligram per liter was 24. In percentage, if we'll see, it will be 10%. 1707 milligram per liter of concentration. The standard deviation was 13 milligram per liter, which will be in percentage 0.76%. For TDS, the concentration in milligram per liter is 293 milligram per liter and standard deviation is 21.20 milligram per liter. In percentage, that will be 7.23%. The sample was analyzed by 77 times by a single lab. For VSS and FSS, the concentration was 170 milligram per liter. Standard deviation derived was 11 milligram per liter, which will be in percentage 6.47%. This sample was analyzed by 3 laboratories for 4 samples and 10 replicates. Okay, so this was the data of measurement uncertainty, or you can say the standard deviation. The source of the information is AFA 23rd edition, method 2540 C, D and E. So this was it about the measurement uncertainty. So friends, this was it about measurement of total solids into the water sample. I hope you have understood everything. We have covered everything starting from the introduction, the definitions of solids, from the equipment, step-by-step procedures, calculation, measurement uncertainty, everything. So I hope you have understood everything, and if you have any doubts or questions, you can ask us in comment. We will try to answer you, and if you have any suggestions for us, the suggestions are welcome. Soon we will soon make another video for measurement of another parameter. Please subscribe to our channel, like the video, and we'll meet soon in next video. Till then, take care of yourself, take care of the environment around you. See you in next video. Till then, bye bye.